morning friends, and again in this video we are starting from solving the some unsolved questions of exercise 7.3 CBSE standard 12. Now in this video I want to challenge myself, like see how fast I can solve this question. At the same time I would like to write most possible and explanatory steps so that it does not create any confusion to your mind. So without wasting your time, let's get back to the question. So here I have the question, which is question number 17. How to find integration of sine cube x plus cos cube x over sine square x cos square x. Sine square x cos square x dx. Now if you see this question directly, find if I write this upon this, then 2 sine will get cancelled and I'll have sine over cos square x, and that is nothing but sec x tan x. So just write here sine cube x over sine square x cos square x dx plus integration of cos cube x dx over sine square x cos square x. That gives you idea of sine x over cos square x dx plus cos x over sine square x dx. This one is sec x tan x, sec x tan x. Sin x by cos x is tan x, and 1 by cos, which is cos square, this gives you sec x. And this is same way, this is cosec x cot x and dx. If you integrate, this gives you sec x. On integration, this gives you sec x, this gives you minus cosec x plus c, and this is the solution. So this is done. Now let me go fast to the question number 18. So question number 18, we have find the integral of cos 2x plus 2 sine square x over cos square x dx. Then without wasting your time, I write, we know that formula of cos 2x is cos square x minus sine square x plus 2 sine square x over cos square x dx. Now in the next line, if you see here properly, that if I this minus cos square x and the plus minus sine square x and the plus 2 sine square, this gives you plus sine square x, and this cos square x plus sine square x will become 1. So I can write this as cos square x plus sine square x upon cos square x dx. This becomes 1. So my integral I now becomes 1 over cos square x dx, that is integration of sec square x dx, and that is nothing but tan x plus c. This is done. Now I go to the question number 19. Now this is question number 19, which goes like I equal to this. How to solve this question? So at the place of 1 you directly write sine square x plus cos square x, sine square x sin plus cos square x upon sine x and cos cube x dx. Let's see if I dissolve, then what I'll get. So I get sine square x upon sine x cos cube x dx plus integration of cos square x upon sine x cos cube x dx. So one more step further, one sine gets cancelled with one sine. I get sine x over cos cube x dx plus integration cos cancel 1 over sine x cos x. Then here I can write this 1 as 2, and there also you write 2, and this will become easier. So now for the first part I say let cos x as t. So minus sine x dx as dt. So my integral I becomes integration minus dt over t cube plus second part becomes 2 over sine 2x dx. So this is minus 1 over t cube dt plus 2 integration of cosec 2x dx, and this gives you minus t to the power minus 3 plus 1 upon minus 3 plus 1 plus 2, and this one gives you log mod cosec x, so cosec 2x plus cot 2x upon 2 plus c. So this 2 cancel. This one is minus 1 over 2 and t to the power minus 2. So you can write 1 over 2 t square plus log mod cosec 2x plus cot 2x plus c, and at the place of this t you can write your cos t. So here I can write this t square as cos square x, and this is your final answer. Now I go for the question number 20. Now question number 20, I is integral of cos x over cos x plus sin x whole square. Now what should I do? Just look at the intuition method. Cos x plus sin x, if you expand, you'll get cos square x plus sin square x plus 2 sin x cos x, which becomes 1 plus sin 2x, and if you substitute 1 plus sin 2x, you'll get cos 2x directly. So it means just I need to expand this, so I get cos 2x, and there I can write this as 1 plus sin 2x dx directly, because I expect everyone knows that cos square x plus sin square x, this is 1, and the 2ab part, that is 2 cos x sin x, is this. So here I write, so let me explain, because some people find it difficult. 1 is whole square as cos square x plus sin square x plus 2 sin x cos x, that is 1 plus sin 2x. Now let 1 plus sin 2x as t, so you get 2 cos 2x dx as dt. So cos 2x is there, so this becomes I is 1 by 2, because cos 2x dx is dt by 2. So this is your 2, and at the place of, you can write here 1 over t dt, that is 1 over 2 log mod t plus c, or 1 over 2 log mod, what is t? 1 plus sin 2x. Now at the same time, if you feel like at the place of 1 plus sin 2x, you can write as cos x plus sin x whole square. Now see, here I remove this part, and then I write cos x plus sin x whole square. Now this goes in the formula of log m to the power n, so this 2 comes on this side, this becomes 1 by 2 log mod cos x plus sin x plus c, this 2 cancel. So your answer is just I equals log cos x plus sin x, and now this is done. Question number 21, find the integral of sine inverse cos x dx. So what to do? We have to get rid of this cos x, and we don't have anything there. So I suggest you, if you use the idea of trigonometry, inverse trigonometric function, it says that sine inverse sine x in its defined domain gives you x. So same way here I can write sine inverse, at the place of cos I can write sine, let me write here in the box bracket. This I can write as sine pi by 2 minus x dx. Now sine inverse sine gives you just integration of pi by 2 minus x dx, and that is pi by 2 integration of 1 dx minus integration of x dx, and this gives you pi by 2x minus x square by 2 plus c. This is the question. This is solved. Now this is question I, is how to find integration of 1 over cos, it is cos x minus a x minus b. This is x minus a, and another cos is there, x minus b. This is actually a special form, and this question is solved like this, because in the numerator I need to have something, so that if I expand that something I get something, so that this sin x and cos x can get cancelled and we can get some considerable form. So just look at these two angles, x minus a and x minus b. So if I say that x minus a minus x minus b, then what you get? You get b minus a. So this is b minus a. Now you attach sine, because what I'm trying to do is I want to multiply something in the denominator and something in the numerator. So there I write, if I go for sine, because sine gives you sine a minus b. This sine a minus b gives you sine a cos b and cos a sine b. So both terms have cos, and I think that one cos will get cancelled by this. So I'll use sine b minus a, and this becomes sine x minus a minus x minus b. So I'll write multiply and divide both sides by sine b minus a. So I write 1 over sine, here I'll write sine b minus a, and here in the numerator I'll write sine x minus a minus x minus b upon cos x minus a cos x minus b integration dx. Now I expand. This is sine a minus b. This is my a and this is my b. So I have sine a cos b minus cos a sine b, because minus is sign in between. So this is 1 over sine b minus a integration of sine x minus a cos x minus b minus cos x minus a sine x minus b over cos x minus a cos x minus b dx. Now if I dissolve this numerator into the two terms, now see, here first term cos x minus this one will get cancelled with cos x minus b. So what you get, sine x minus a over cos x minus a, that is tan x minus a, and at the same time when you write this upon this, then the cos x minus a will cancel with this cos x minus a, and will give you tan a minus x minus b. So since you understand this part, I just go into the right part or the next part directly. So here I write this as 1 over sine b minus a integration. I am writing this directly as tan x minus a dx minus 1 over this sine b minus a is common to both. So here also I'll have sine b minus a integration tan x minus b dx. Now you know that integration of tan x is log sec x. So I keep this term common, sine b minus a outside. This becomes log sec x minus a minus log sec x minus b plus c. If you feel like that, you know that log m minus log n is log m by n. So I remove this part, and here I write this as sec x minus b, and this is done. So this is the answer of this question. So in this exercise we have just 2 more questions left. Now question number 23 and question number 24 are MCQs. So we should try to solve them as fast as you can. So sine square x, if you can do it orally, that is much better. Sine square x minus cos square x over sine square x cos square x dx. But since this is MCQ, now you go directly. Sine square x over sine square x cos square x, this gives you 1 over cos square x dx, minus cos square x over this gives you 1 over sine square x dx. 1 by cos square gives you integration of sec square x dx, minus this gives you integration of cosec square x dx. This one on integration gives you tan x. This one on integration gives you minus cot x. This becomes cot x plus c. So we have option number A, that is correct. Done. Because in MCQ you should not write each and everything, you can just write the answer directly. I could have written the answer here directly only, but since I have to explain, that's why I wrote these 2 terms, intermediate terms. Now question number 24, it is just also MCQs. E to the power x 1 plus x over cos square x e to the power x. So dx, you see properly, if you take x e to the power x as t, then find differentiation, UV rule. So x unchanged, differentiation of e to the power x, e to the power x plus e to the power x unchanged, differentiation of x, that is 1 whole dx as dt. Now you take e to the power x common, you get x plus 1 dx as dt. So here you see that on the numerator you have dt, denominator you have cos square t, that gives you sec square t. This gives you integration of tan t plus c, that is tan x e to the power x plus c. So the option number B is the correct, tan x e to the power x plus c. So option B is the correct. And now we have done exercise 7.3. In the next video we'll start solving 7.4. Thank you very much. Just subscribe to our channel and press the bell icon so that whenever we make any updates in the video, you can understand them immediately. Thank you very much. Have a nice time.